So today we're going to talk about understanding exponents and equations. So first let's see if we can make sense of what an exponent actually is. So we start with this first one, 2 squared. And there's no problem figuring out what 2 squared is. You know, most people say 2 squared is the same thing as 2 times 2, which is equal to 4. So if you have a natural number for an exponent, it's usually pretty easy, you know, so like 2 cubed is 2 times 2 times 2. Integer exponent really isn't that bad either. So when you have a negative in the exponent, it just means put it in the denominator. So it's really 1 over 2 to the 1. Or if you had like 2 to the negative 2, that would be 1 over 2 squared, which is 1/4, and so on. So integer exponents aren't really that hard to understand either. Then we come to rational exponents. So this tends to cause a little bit of confusion. What does it mean to have a rational number in the exponent? It's not really that hard to understand, but it's kind of like a reading thing, so you either know it or you don't. So if you have 2 to the 1/2, what that really means is that this 1 is sort of the nice part, so it's like the 2 to the first power, and then this 2 in the exponent, which is in the denominator, is actually the root. So there's really a 2 here we don't normally write. So it's really just the square root of 2. If you had something a little bit more complicated, like let's say you had 2 to the 2 thirds. So what this would mean is you could have this good part right here, which is the 2, and that's the easy part. That's the part we can kind of do, so that's like 2 squared. And then you have the 3, which is the denominator in the exponent, and that's what the bad part. That's the thing that we usually can't do by hand, so that's the cube root. So what that means is the cube root of 4. And of course you can check all these all on your, not 4, yeah, cube root of 4. You can check all these on your calculator if you want to. So, you know, if you have 2 to the, so 2 to the 2 thirds, you can see here what that's actually equal to. It's 1.587 blah blah blah, and you can actually check to see if that is the cube root. So there's a cube root button, so here you can use the cube root, so cube root of 4, and see that these are exactly the same. So you can kind of use your calculator sometimes to check to see if you really do know what it means when you have a rational exponent. Now as we move on to sort of the real numbers and the complex numbers, these get harder to sort of explain, and we actually need e's and ln's to do this. So we're going to have to hold off a little while, but so to really understand what 2 to the root 2 is, we're going to need to understand a little bit about what we mean by e to the x and ln of x. But once we understand these two concepts, we can kind of make sense of how we compute this number, 2 to the root 2. But of course your calculator can always compute it, right? You can do 2 raised 2 and then second root 2. We just don't really understand what it's sort of doing when it makes that calculation. But we will eventually once we start talking about e to the x and ln of x. And of course complex exponents are even harder to understand, so we need to know a little bit about trigonometry really to understand what 2 to the I really means. All right, so the point of this is to kind of explain to you that exponents are not simple. They can be kind of complicated to understand. Fortunately, we're not going to get into any of the real sort of complexities here. What we really want to do, is just sort of understand exponents. And then as you guys sort of mature mathematically, you'll start trying to understand what they really mean. So understanding exponents, first we're just going to work from a calculator. So we have a couple of calculator problems to do to make sure that you can use a calculator to work with exponents. And so let's do these. So it says approximate each number with a calculator to 3 decimal places. So it's pretty simple. We want to do 6 to the negative 2 thirds, so we just hit 6, and then the caret button puts us in the exponent, and so we raise it there, and then we hit negative. I think this thing just crashed on me, so I got to close it here. Let me open it up again. All right, let's try this again. So we're going to hit 6, and then raise to the negative 2.3, and then hit enter. and it spits out the answer. And we want it to 3 decimal places, so we'll look at the 4th decimal place here to 2, so we'll just drop it off. So 0.16. So this is approximately 0.016. And then we'll do e to the square root of 5. So the e button is actually right behind this ln button. You can see here it says e to the x. So you hit second to get to the blue stuff, the blue button, and then e to that, and then we'll put the square root of 5, so second square root of 5, and hit enter, and it'll spit back this number into 3 decimal places. This is a 4, so we just drop it off, and we get 9.356. So this is approximately 9.356. And if you're not familiar with the number e, you can find out what e actually is here. If you hit second ln into the 1, I'll tell you what e is. E is just this number, 2.718, blah, blah, blah. We'll talk more about this later, but e is sort of a number that pops up when you're talking about growth or decay. Sort of like pi is a number that pops up when you're talking about circles. All right, so that's how we work with exponents in calculators. And then the next thing we want to talk about is we want to talk a little bit about the properties of exponents. So here are the properties of exponents, and you should have this handout. I gave it to you guys in class here. So the properties of exponents, there's several different properties. You know, you have a 0 exponent rule, which is basically the idea if you take anything to the 0 power, you get 1. You have a negative exponent rule, which is you have something to a negative power, it means 1 over that thing. You have a product rule, which tells you what you do when you multiply exponentials. So when you multiply exponentials with the same base, you add exponents. When you divide exponentials with the same base, you subtract exponents. And then we have these power rules, which have to do with when you have exponentials or things and you're trying to exponentiate them. So when you have b to the m to the n, you multiply exponents. And then exponents go through multiplication, and they also go through division. And then finally down here we have this radical versus power notation, which tells us how we rewrite a radical in terms of power form, or you can say how we write power form in terms of radicals. Now you don't have to have all these memorized, but you should know how they work and how to use them. So let's take a look at an example here, and I'm going to do this example in 2 different ways. So here's our example. First I'm going to do it using the actual properties. So we're going to start by trying to use the properties of exponents to see how these properties actually work. And then I'll redo it using just my sort of intuition. So using my intuition, using the rules first over here, what can I do? So you look at this thing and you try to find a rule that sort of best matches it. So you basically, what you have is you have something on top and something on the bottom, and it's all being raised to a power. And so you come over here and you look for something like that, and I think this rule right here, the power rule part 3, looks most like that one. So what we can do is by that power rule part 3, we can rewrite this. We can rewrite this as the top to the nth power divided by the bottom to the nth power. So in this case, the nth power is -3, so you can rewrite this as 2 to the x to the -3 divided by x to the 6 y to the -5, all raised to the -3. And then we look at this and we think, okay, well, is there a rule over here that we can use that matches up with this sort of stuff? And so basically it looks like you have something here to a power and you're multiplying these two somethings. So I think that one, we could use rule 2 on the top and the bottom. Right? So we'll use rule 2 here, and we'll rewrite this as 2 to the -3 and x to the -3. Because look at this rule over here. It says a times b to the n is a to the n times b to the n. And remember, I'm not using my intuition at all. I'm just basically, this is what I call a picture replacing process. I see a picture and I replace it with what it says it's equal to. And then here on the bottom you have 2 things you're multiplying. So I'm going to raise both of those things to the -3. So I have x to the 6 raised to the -3. And I have y to the -5th raised to the -3. So again, I'm just using this property 2. Right. And so then we look at it again and say, okay, well, how else can we simplify this? Are there any other rules we can use? And so the next step might be, I look at this bottom part and I have this sort of exponential to another power. Oh, and that looks like to be this rule. You have some sort of exponential to a power, so you multiply exponents. So I can rewrite this. We'll keep this the same on top. We won't mess with that right now. And then I can rewrite this bottom as x to the negative 18 times y to the negative 5 times negative 3 is positive 15. So I just multiply exponents. So I'm using this rule 1 not once, but actually twice. I'm using it here and here. All right, so what's the next thing that I can do? I guess I can rewrite some of this stuff if you want. So I have a negative exponent property, right here, exponent rule right here. And what it says, if it's a negative exponent, that means you can move it to the bottom. So maybe before I apply that, I'll actually rewrite this stuff because I think it might be better if I rewrite it. So let's rewrite it. Write this as 2 to the negative 3 times, and I'll rewrite this as x to the negative 3 divided by x to the negative 18. So I'm just going to separate the terms out, put the likes kind of together, and then times 1 over y to the 15th. So this is not a rule over here, right? So it's not a property of exponents. This is actually a property sort of arithmetic, a property of multiplication. Okay, so now what I'll do, right now I'll use this negative exponent rule right here. And this negative exponent rule says this 2 to the negative 3 is really 1 over 2 cubed. So that's by that negative exponent rule. So maybe we'll just let's write this as, how do you want to write this? Let's write this as rule 0 and rule 1. So by rule 1, I guess we put circles around these so you know that they're not really part of the problem. I'm just stating my rules that I'm using. And then, so that's by rule 1. And then now this, we can simplify. You kind of look for a rule that matches up with this one. So you have x to a power divided by x to a power. So that looks like this thing right here. So this is that quotient rule. So by that quotient rule, we can rewrite this as x to the negative 3. And because we're dividing here, we can subtract. So minus negative 18. Right, so that's by that quotient rule. So below it, we can just write quotient rule. And then here, I'm going to leave this one alone. There's nothing we can do with this, 1 over y to the 15th. And so what's this equal to? So we have 1 divided by, and that's an 8. So we put an 8 here, it's 2 cubed. And then we have x to the, a minus is a plus. Now is 18, so that's really negative 3. So it's really negative 3 plus 18, which is a positive 15. And then times 1 over y to the 15th. And that's basically as far as we can go. We can put this back together and get x over 15 divided by 8 y to the 15th. And that's our answer. Now that's sort of a roundabout way to get at it, but the idea is, do you understand how to use these properties of exponents? And it relies not a bit on my intuition. What I am doing is I'm just looking at these pictures on the left and then replacing with them on the right. And then that's what we mean by simplifying the expression. Now I'm going to do this again because I wouldn't normally do a problem like this, like that. The reason is I can use my intuition, and my intuition moves a lot faster than the rules do. So when I use my intuition, I'm sort of reading this thing. So when you have a negative in the exponent, remember that what that means. It means the stuff on top can go to the bottom and stuff on bottom to the top. So what that really means is I can rewrite this as x to the 6th, y to the negative 5th, divided by a 2x, and that's still all cubed. I just took care of that negative sign. And then I know what it means to cube something. You cube each thing inside. So I'm going to cube this, 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 and this. So I'm going to cube the x to the 6, which is going to give me x to the 18. I'm going to cube y to the negative 5th, which is going to give me y to the negative 15. And on the bottom, I'm going to cube the 2, which is 8. And I'm going to cube the x, which is x cubed. And then I'm going to cross off what they have in common. So I have 18 of these and 3 of these. So it leaves me with 15 of these on top. That negative in the exponent means put y in the bottom. So I have an 8 down here and y to the 15th. So when I use my intuition, things move a lot quicker. Remember, where does my intuition actually come from? It comes from working with numbers. Right? The reason why I know x to the 6 when you cube it is x to the 18 is because I know if you take 2 cubed and you square it, what's that going to equal? It's just 2 cubed times 2 cubed. But you add exponents there, so you get 2 to the 6. So you multiply exponents right here. 3 times 2 is 6. You don't add exponents. 3 plus 2 is 5. You actually multiply exponents. And so I carry that intuition over here when I abstract it, basically. And I see that I'm supposed to multiply exponents there and get 18. It works a lot faster, but both ways of doing this are important. All right, so let's take a look at the next thing we want to do. So we talked about the calculator. We've talked about properties of exponents. Remember, you don't have to memorize the properties of exponents, but you should know what they say, basically. And the last thing I want to talk about is solving exponential equations. So here are the examples we're going to do. All right, so we're going to do 5 examples, and they basically build on each other. And we start with a really simple question. 3 to the x is equal to 5. And these are called exponential equations, of course, because we have exponentials, 3 to the x. And we want to figure out, for what value of x do you plug in here to get 5? Now, some exponential equations are easy. You can just look at them, like 2 to the x is equal to 4. So you can just look at this, and by inspection, you can say, oh, x is just equal to 2. Because if you square 2, you get 4. But now this one's not so simple. You can't really just guess and check. I mean, it's not 1, because if you plug in 1, you get 3. You know the answer is actually between 1 and 2, because if you plug in 2, you get 9. So there's some number between 1 and 2 that you're going to plug in here, and it's going to give you 5. And we want to find that number. And the way that we do this is we use a tool, another function actually, called the ln function. So ln of x. All right, so we're going to use this function as a tool to solve these equations. So what we do is we say we ln both sides. And when we ln both sides, what happens is that this exponent gets to come down in front. All right, so think of ln as just a tool right now that unlocks exponentials. It unlocks exponents. All right, so it's going to unlock exponents. It basically takes exponentiation and turns it into multiplication. So what we're going to get here is x ln of 3 is equal to ln of 5. And then we can solve this for x. And you have to remember, ln of 3 is a number, so you have to treat it like you would a number. Right, so you take this, and ln of 3 is all of one thing. You don't just divide by ln, you have to divide by ln of 3. And over here to divide by ln of 3, both sides. The ln of 3's will cancel, and we'll get our answer, x equals ln of 5 divided by ln of 3. That's our answer, and we can check it with our calculator. So on your calculator, you'll see you have an ln button, so you can hit ln of 5 in parentheses, divided by ln of 3 in parentheses, and then hit enter, and out pops this answer, 1.46497, blah, blah, blah. It goes on forever and ever, probably never really repeating. And you can check, if you take 3 and you raise it to that answer, so second answer, you see you get out 5. If you want to round it, you can, but you always have to have the exact answer. So if you want to write down 1.46, I have no problem with that. You could say approximately 1.46. But make sure you have the exact answer down, because this is the answer, not 1.46. It doesn't say solve x approximately for x. It says solve for x. And so x is the answer, ln of 5 divided by ln of 3. Let's go to the next one. So here I have 5 to the 3x equal to ln of 7. So again, what are we going to do? We're just simply going to ln both sides. Always on the left-hand side too, never on the right. And if we ln both sides, this 3 to the x will come down in front. So remember, ln is just a tool that's going to unlock exponents, and it's going to turn that exponentiation into multiplication. So you have 3x ln of 5 equal to ln of 7. And so now we need to move over the 3 and ln of 5, and so it's pretty easy to do. Remember, ln of 5 is a single thing, it's one number, so we're going to divide out by the 3, and then also the ln of 5 on the left and the right, so we don't change the equation at all. And we get our answer. X is equal to, on top you have ln 7, and on bottom you have 3 ln of 5. Over here, the ln of 5 cancels here, and 3 cancels here, and you're left with that x. And so this is my answer. You can test it with your calculator, but be careful. So when you test this with your calculator, you have to hit ln of 7 in parentheses, divided by, and here's where you have to be very careful. You can't just type 3 ln of 5, otherwise it'll be wrong. Order of operations will actually say divide by 3 and multiply everything by ln of 5. So we need an extra set of parentheses on here. So parentheses 3 and then ln of 5 in parentheses. So here you get out about 0.40. So if you want, you can write down next to it. I have no problem with this because I have the actual answer, 0.40. But the actual answer has to be there, and you can test this thing because you can take 5 raised to 3 times second answer, and we better get out 7 if we did this right, and we get out 7, so we know we did it right. All right, so let's look at C now. So we're just sort of building on what we've been doing. So on part C, what do we have? So we have this 5 times 7 to the 2x equal to 20. Now before we can ln both sides, we need to get rid of this 5. All right, so the rule that we're actually using, which we'll learn later, is if you have ln of x to a power, it turns out the power can come down in front. So this is the property we're using of logarithms. So we need to get rid of that 5 first, and then we can ln both sides, and then that power can come down in front. So it's easy to get rid of the 5. You're multiplying, so to move it over, you just divide. And when you do that, we get 7 to the 2x on the left, and you get 4 on the right. And so basically now we're back into this situation, which we were before. And so now we want to bring the 2x down. So we'll take out our ln function basically. So we'll ln both sides. ln is just this tool that unlocks exponents. So this 2 to the x will come down in front. And so we'll get 2x ln of 7 is equal to ln of 4. Right, you don't have to draw this arrow. It comes down in front. I always do it just to show you what's happening. And then we'll simply divide out by the 2 on both sides. That cancels the 2 there. And then also the ln of 7. Remember, ln of 7 is one thing. It's a number, so you can't separate it. So you have ln of 7. And that's our answer. So x is equal to ln of 4 divided by 2 ln of 7. And again, you can check this on your calculator to see if it's right, and you can do that since I've already done 2 of them, but you can check it, make sure that it's the right answer and that we didn't make any mistakes. And then come here to part D. Let's look at it because we had one more step. So in C you had this right here, which is sort of similar to this right here. Then we have this additional minus 2, but it's not hard to work with. So the idea is first you'll add 2 to both sides to move over the 2. And we'll get 3 times 1.5 to the 3x is equal to 18. And so now this equation reminds us hopefully of this equation. So in order to solve for x, first we need to get rid of the 3. So we'll divide out by the 3, both sides. And this will lead us to 1.5 to the 3x is equal to 6, because 18 divided by 3 is 6. Next, we'll ln both sides. So we're going to ln the 1.5 to the 3x. And then we'll ln the number 6. And the reason we did this is because we're trying to solve for x. We got to get the x out of the exponent. So the only way to do that is to ln both sides, because the property of ln's, or logarithms in general, is a 3x will come down in front. And so we'll get 3x times ln of 1.5 is equal to ln of 6. And then divide out. We want to solve this for x, so we'll divide out by the 3 and the ln of 1.5. So divided by 3, ln of 1.5 on both sides. And what happens is we get our x equal to, on the left, and on the right we have ln of 6 divided by 3, ln of 1.5 for our answer. Again, you can check that by plugging this into your calculator, and then plugging x into here and seeing if you can actually get out 16 in the end. Okay, the final one that we want to do, part D, it's a bit tricky. I found students really struggle with this one a lot because you really have to abstract from something that you do quite naturally. So the first part's easy. There's no addition or subtraction you have to do. You just have to get access to these exponents. So we're just going to ln both sides. There's no problem with this. Remember, always ln on the left-hand side, not the right. It doesn't make any sense if you ln on the right because the ln has to hold on to something. And then these powers will come down in front. So these exponents can come down in front. So hopefully you see how the ln, what happens, it takes exponentiation and it just turns it into multiplication. So you have 4x minus 7 all times ln of 3, and then equal to, that x comes down in front and you get x ln of 5. And this usually doesn't cause much trouble. Now you want to solve for x. So the idea is you need to multiply through by that ln of 3. So I'll multiply through to unlock the x stuff by ln of 3 here and here. So you get 4x ln of 3 and minus 7 ln of 3 equal to x ln of 5. And remember, what we're trying to do is solve this for x. So what we want to do is get all the x stuff to one side. So I'm going to move over this constant, 7 ln of 3. We'll add that to both sides. And there are lots of ways to do this. I'm just going to do it the first way that kind of comes to my mind. So I'll add that to both sides, and I'll get this now. I get 4x ln of 3 is equal to, and I have x ln of 5 plus 7 ln of 3. And then I'll move over the x ln of 5, so I'll subtract that from both sides. So now at least I'll have all the x stuff on one side. And so over here, I'll write 4x ln of 3 minus x ln of 5, and it's equal to 7 ln of 3. And then this is typically where students will get stuck. And they get stuck because they're not used to adding and subtracting x's that they're not familiar with. Like for example, if I wrote down 4x minus 3x, you would just tell me that you get back x. Because you say 4 things minus 3 things is x things. Well, the reason you can do that really fast is because you understand 4 minus 3. This one's a little bit harder because what you have is 4 ln of 3's and an ln of 5, which you don't know what those values are, so you can't do those subtractions quickly in your head. So you have to kind of go about a different way, try to figure out a different way to solve this problem, which you just basically do naturally. And the trick of it is you have to pretend like you don't know what 4 and 3 is. So you have some quantity of these minus another quantity of these. How many of these do you get back? Well, you can just factor out the x. Right, so how many x's do you have? 4 minus 3 of these. You know 4 minus 3 is 1, but if you didn't, you could write 4 minus 3 of these. And the same thing's going to happen here. They have an x in common, so we'll just factor it out. And if you factor it out, this problem is basically done. So you take out x, something minus something, and of course it's equal to 7 ln of 3. And the something that goes here times the x is what? You look above and oh, it's just the 4 ln of 3. Right, so you just put 4 ln of 3 here. So it's clear this times that is that. Over here you just put the ln of 5 because it's clear this times that is that. But you'll notice you no longer have an x inside here, so now you can solve by dividing out by 4 ln of 3 minus ln of 5 on the left, and then make sure you also do it on the right, otherwise we'll change the equation. So 4 ln of 3 minus ln of 5. And we get our answer, x equals 7 ln of 3 divided by 4 ln of 3 minus ln of 5. And again, you can check this with your calculator. You can plug this in and find a value for it, and plug that value back in for x. You get a number over here. Plug it in for x over here, you get a number over here, and those numbers should be exactly the same. All right, the very last example we're going to do, we want to do a problem with technology again. So far we've solved linear equations, quadratic equations, rational equations, and today we learned how to solve exponential equations. But remember, most equations cannot be solved by hand. Right? So most equations you have to have some sort of technology to solve them. So in this situation, what we want to do, or this example, we want to use your calculator to solve the following equation, which cannot actually be solved by hand, and then round your answer to 2 decimal places. So it's actually pretty simple to do. All you're going to do is you're going to graph the left-hand side of this equation, graph the right-hand side of this equation, and see where they intersect. So hit y equals, and then plug in 3 raised to the x, and then add 1 to it. Hit enter, and then do x squared plus 3x minus 5. So that's the right-hand side of that equation. We really don't know where to look, and there's no context to this problem, so we don't even know where to guess. So if that's the case, we always do a standard window. So just go to Zoom and go down to Z standard. It's a -10 to 10 window, and hit enter, and you'll see here's the exponential function actually, and then there is the graph of x squared plus 3x minus 5, and hopefully you see that it intersects right there. And so what we can do is we can actually draw a picture of this to kind of show our work. So what did it look like? It looked kind of like this. And then it had this one kind of going up like that, right there. And we're looking for where it intersects. So you want to find this point right here. And that input value, that x value, will be the answer that solves this equation. So on your calculator, all you have to do is hit second trace, go down to the intersect, so number 5, and then first curve, second curve, you just hit enter. It jumps to the other curve, you hit enter, and then give it a guess. There's only one place where it intersects, so hit enter, and let's see if it finds it. Yep, it found it right there. It's actually kind of blinking at you. And so to 2 decimal places, this would be, x would be negative 4.37, because that's a 3. So my x value, so x is approximately, that should be wavy lines, it's approximately negative 4.37. And we should say kind of what we did here, we'd used intersect. Right, so we used the intersect to actually find that. Now you can check your work by trying to plug this point into here and seeing what you get versus plugging your point into here to see what you get. But remember, the answers will not be exactly the same because we rounded, so they may be a little bit off. But that's how we use technology to solve equations, basically. All right, so that completes this lecture. Right, so hopefully, you understand a little bit about what an exponent is. You can use your calculator to sort of, work with exponents. You don't have to memorize the properties of exponents, but hopefully you understand what they're saying when you see them, and then you can apply them in a situation using more of your intuition. And finally, hopefully you can solve some basic exponential equations, at least the ones that I just gave you.